Welcome everyone to this course, the Advanced Computer Architecture course. So this course is the English speaking course. So I know sometimes it's not easy to understand the English lecture. So so I'm not a native English speaker. So sometimes it may be difficult to understand. So if you have any difficulties for understanding the lecture contents, then raise your hand and ask the questions, right? So I know that this is the graduate course, and then usually the students in the graduate course are so very passive, so it's very silent actually during the classes. So there are no interactions. There are I cannot find any reactions among the students in the graduate course, but not good actually. So this is the first class of this course. I will briefly introduce about the course, and then I will finish the lecture. So fortunately, we have two classes per week. So we can start some new topic on the next class. So I think my frozen. Mm. Oh, mm. So why do you why why do you pick this course? Why why did you select this course for some graduate courses? So actually, the name of this course is Advanced Computer Architecture, and I believe the most of you already took the computer architecture course for undergraduate students. So as you can see, you can find the name Advanced. So actually the difficulty and then the topics covered by this course will be more advanced topics. So actually actually around maybe for 2 or 3 weeks, I will read what you learned in the undergraduate computer architecture course, such as the instructions and architecture, and then pipelining architecture. But after that, I will cover the advanced topics on computer architecture, such as the out-of-order process architecture, and then parallelism, and then some other architectures such as the CMD or BLIW, and the large instruction word. And so I will cover some advanced topics on memory systems or memory hierarchy. And then I know that this is some basic course for graduate students, and then in the computer engineering department, this this course is included in the graduation exam, 종합시험. So that's why I believe that's why you are taking this course. But so my plan is that so you are graduate students, not undergraduate students. So it means that you need to focus on research, and then so the research is a little bit different from study or learning. So actually, I hope in this course I can cover some research topics, and then I hope this course can be helpful for your future research. So actually, this is the computer architecture course. So I will also cover some basic. I mean basic. So that means old-fashioned. So as you know, so recently, no processors include simple five-stage pipeline like inner process architecture. So most processors employ out-of-order process architecture. So actually, the one you learned in the undergraduate course is the outdated topic. No one studies some topics you learn in the undergraduate course. Okay? And then, so I hope, so, and actually, so I also covered some old-fashioned topics, such as the out-of-order processor, AAA514, and then those are more advanced topics. Okay, so and then so I hope so you can learn about the advanced architecture or advanced topics on computer architecture, and then also I hope these topics can be helpful for your research, future research. Okay. So, object of this course, the object of this course, exploring the advanced topics. As you can see, you can find the advanced compared to the undergraduate course. Okay, advanced topics on computer architecture, and then so I will cover these topics in this course. Okay, so firstly, I will introduce about some semiconductor technology. Okay? The processors are the product of semiconductor industry. It means that so actually so we can build the CPU chips or GPU chips using semiconductor technology. Okay? So the performance and then some other costs of these processors are highly influenced by current semiconductor technology. Okay, so that's why the semiconductor technology is very critical for some performance and cost of the processors. So firstly, I will cover briefly. So I'm not an expert of the semiconductor related area, but I will briefly explain about some semiconductor technologies on the processes. And then, so we will also focus on, we will cover the performance metrics, such as so we need to measure the performance. Well, we need to compare the performance of two different systems when we perform some researches. When we do researches, so we need to measure the performance by performance of architectures, or performance of processors, or performance of computer systems enhanced by your ideas. Or we can also compare the performance of two different systems. So we will so I will cover this performance metrics. Okay. And then this is just a review. The pipeline processor architecture. So it means the in-order processor architecture. Okay, so this is just a review, but we need to cover the basic concept of in order processor architecture. It's very important, it's very critical for understanding the processor architecture. And then, so this is the main topic, and then also this is the very important topics for the graduation exam in the computer engineering department. And then, so we will cover out of order processor, the modern out of order processor architecture, and then speculation. So this is very important topics in this course. Okay, and then terrorism. Okay, there are many different. How can I say it's a method? Many different kind of terrorism. So different kind of terrorism can be applied to the processor architecture. So we will cover different kind of terrorism, and then memory systems, domain-specific architectures briefly. Okay. So also we can also cover some GPU, the graphics processing unit, okay, in this course. Textbook. So I will mainly use this textbook. It's Parallel Computer Organization and Design, written by Michel Dubois, Brian Abraham, and the first 20. Okay. So, and then actually for this course, I will use slide, and then so I will also provide the list of research papers. Okay. And then also this course includes design labs. So my plan is that, and then also my hope is that this course needs to be helpful for your research. And then also this course is the computer architecture course. So I hope the topics covered by this course can be helpful for your computer architecture research. Okay. So I will introduce several simulators, and then usually we use simulators for the computer architecture research. So so I will provide several design labs. So it's a kind of just that design, so that's just the labs. Okay. So and then in these labs, so we will explore how to use architectural simulators. Okay. So and then those are additional additional books. The computer architecture of quantitative approach is very popular book. So and then I use this book, Computer Organization and Design, for the undergraduate course. Okay. Related to course, verification, I strongly recommend it. So I expect most of you can understand the basic pipeline architecture covered by undergraduate computer course. That's my expectation. So in the undergraduate computer architecture course, I cover the very detailed architecture of the in order, actually the 5 stages in order processor architecture. So you need to understand also. So another important topic covered by this undergraduate course is the memory hierarchy. So I expect the most of you can understand the concept of pipelining, also the concept of memory hierarchy. Okay, so this is not very clear, and so C. You need to understand how to write C code. Okay, so not Python. So C, So I believe everyone knows the differences between C and Python, right? C is the compiler-based language, and then Python is the interpreter language. And then, as usually, the system researchers use C or C++, but Python is kind of a script language. We can use the Python like some script for writing script or some framework like machine learning framework. But actually, when in order to understand the architecture of the computer processor, or in order to manage or control the hardware components of the computer systems, then we need to use C. Okay? So I expect everyone can write a code using C. And then this is also required for lab. So you need to be familiar with the Linux command line interface and Docker. I will provide the Docker file, and then actually the most of that's my claim. Not most of that. So we will use Docker in Korean Docker. 도커긴 한데 한국에서 도커인데 Docker 닭이거든요. 닭 이걸 쓸게 닭. So I provide a Docker environment for that. Then so please get familiar with the Linux CLI or and Docker commands before performing the lab assignments. Okay, it's a very convenient tool, Docker, actually. So the container tool, then we don't need to set up some specific dependencies for using simulators. So these are prerequisites for this course, and then I will briefly introduce about the related course provided by computer engineering department. So this is the basic course for graduate students. Even though this name of this course is the advanced computer architecture, but this is the basic course for graduate students. And then but we provide some several courses related to computer architecture research, like the AAA514. This is parallel process architecture. And then in this course, we will cover memory systems for CMP, chip multiprocessor, and then synchronizing some parallel processing issues such as the synchronization and coherence and consistency. So is the very tricky concept. Okay, coherence, but you need to understand. You need to understand the coherence and the consistency in the parallel processor architecture. And then the 649 is the GPU architecture. 650 domain-specific architectures. And then the 634 is the advanced processor architecture. And 751 is the storage system. So these are related codes and provided by computer engineering department. Okay? This is me. And then who? And then my research area is computer architecture, right? And then if you are interested, you can visit the web pages. Okay. Okay. And then we can use, I will use Blackboard for class management. Yeah, so I will post some announcements and assignments on Blackboard. So Blackboard provides the links to Piazza, and then so I use I usually use Piazza for class management, not Blackboard. Blackboard is it's not convenient. Okay? But uh, as I mentioned, the graduate students are not enthusiastic for attending some class activities, but instead they are excited. They do not post questions, even though I made some Piazza one Piazza area, the Piazza for the graduate courses, but nobody attended. Nobody posted questions on Piazza. But I still made it. So, so on the Piazza, you can post the questions, and then you can get you can. I will. So the problem is that I may be very busy, so I cannot. I may not post the answers immediately for your questions, but I'll try. Okay, so this is Piazza that you can sign up as a student. You can join as a student using this access code. So access code is the Dumbledore who is him. 아는 사람 있잖아요. Dumbledore who is him? 해리포터 나와. 해리포터는 Dumbledore. Okay. And then I also post the slide, like a slide, and then papers, research papers, and some material on Piazza. So anyone can post questions and answers. Also answer. You can post the answers. Like this. So this is the example of Piazza for undergraduate course. So undergraduate students actively participated in Piazza. This is conducted the course for undergraduate students. And then also you can find the resource tab. Then I put the lecture slide and hopefully lecture videos. So this is class time. So we have 2 classes per week. 1:30 to 2:55. And then grading policy, so kind of two. So that's the plan. So we will take one final exam. So we will not take midterm exam. So it means that the final exam will cover everything we learned in this course, right? So we will take one final exam and then several assignments, and then paper reading. And then lab assignments, and then research project. Okay. So as I mentioned, I hope this course can be helpful for your research. Okay. So actually for this course, this is my third course. Means that I taught this course in 2020, 2022, and then this year, and this is my third time. That's what I hope. I will focus on some research. Okay, so I will focus on some paper, lab, research project for this course. So exam is the on-site exam, closed book. Okay, then you can use Korean. You can answer in Korean. So even though this is the English teaching course, but it means English teach. Okay, you don't need to use English during the classes. So you can answer in Korean. Yes. So problem is there. Sometimes I cannot understand English writing. Student English sentences student wrote. But sometimes the grammar was wrong. But it was difficult sometimes. Okay, paper reading. I will provide 6 to 7 paper critic assignments. So critic means 비평. So, and then this paper critic will include the summary of the paper, and then you need to include the motivation of the paper, and then ideas, the main ideas in the paper, research paper, and methodology. The methodology is that how the author's ideas are evaluated. Okay? The methodology. And then you can briefly include the strengths and weakness of this paper, and then some comments. So this is the paper critic assignment, and then my plan is that I can provide this assignment every 2 weeks. Okay, so I believe there can be around the six to seven assignment. There can be around the 6 to 7 critical assignments in this course. And then it's important. Do not use any AI tools, okay, like ChatGPT or Copilot. Why? We can use AI tools for our research. That's okay. That's okay. But as a student, you are learning. Okay? You are learning some topics, or you are learning some research related contents in this course. But if you use AI tools, so it means that it can just generate a very good result, but it's not your result. It's the result from machine, result from computers. But the problem is that the goal of this course is that you need to study something, you need to learn something. But if you use AI tools, then AI will learn, but you will not learn anything. That's the problem, right? So do not use any AI tools for this paper assignment, paper critic assignments. I know sometimes writing, English writing is not easy. You know, I understand because I'm not a native speaker, right? But practice is required. You need to practice. You need to practice writing. You need to practice reading English material, research papers, right? That's why I plan to provide this paper critic assignments. Okay? Never use any AI tools for this paper critic assignments. Okay? It can be very helpful. I believe this assignment can be very helpful for your research. Okay? Also, reading research paper is very critical, very important for your research. After your graduation, it's also very important. Okay? We need to understand. We need to practice reading and writing some English paper. Okay? Later, so lab assignment. So I mentioned that so we frequently use architectural simulators for our research. So this is because this is the hardware related research, but very, very difficult to modify hardware. Why? Why? Hardware is hard. It's not soft. So it's very difficult to modify hardware directly. So that's why we use simulators, because simulators just emulate the operation of a computer hardware, computer systems, or computer processes, and then it's software. So which means that we can modify the code, or we can add our ideas. We can modify codes in architectural simulators. So I hope so. This course we can explore several architectural simulators. So that's why I will provide some lab assignments. Okay. So this is some expected assignments like the risk of 5 do it yourself simulators. What does that mean? You need to make your own simulators. Okay, like a risk 5 instruction simulators. Okay, and then risk 5 code compiler and instruction simulators. So we just practice the compilation by risk 5 ISA, and then we just practice the risk 5 instruction simulation. Okay? And then the first one is so you need to design your own computer architecture simulator and instruction simulator. And then so these are already you can use some open source simulators. Okay, you don't need to design your own simulators for this from the second line. And then so we will practice using GM5, so very popular process architecture simulator. And then DRAM simulator. And then GPU simulator. And then some others. Okay, so we can explore some. So I provide also 5 or 6 lab assignments for this course. Maybe five or 6. Okay, and the result problem. Also, as I mentioned, the writing is also important. So, okay, this is the final project for this course. So you can select your own research topics regarding the computer architecture field. Okay, and then you can write the research paper using LaTeX. So LaTeX is it's also language for documentation for example. So we can use the LaTeX template, and then we can write some paper, and we can compile the LaTeX document to generate a very fancy or organized paper. Okay, so I will provide the components paper template, and then using this template, then you can write your own. You can write your own research paper, and then using your own research topics. So that's why I will provide this lab assignment. So using the architectural simulators, you can develop your research ideas, and then you can just evaluate your ideas using architectural simulators. So by choosing any simulator, and you can choose your own research topic, and then you can write down the research, pick your own research paper. Okay, and then finally you can present to your project result. Okay, so those are my plan for this course. Okay, and then so any questions? To myself. 뭐 저기 한국생들만 있나요? Any foreign students here? 어? 그러니까는 말했듯이 약간 이제 리서치에 좀 도움이 될 만한 그런 컨텐츠로 좀 진행을 하려고 합니다. 이런 토픽들도 이제 좀 배우긴 해야 되는데 배울 거예요. 토픽을 내가 안 가르치는 건 아니니까. 토픽도 이제 배울 건데 어쨌든 이런 리서치 여러분들 이제 리서치를 이제 잘 할 수 있도록 좀 이제 이 코스에서 이건 잠깐 이제 들어가 리서치를 위한 기본 그런 것들을 좀 기르면 좋겠다 그런 생각이 있습니다. 재밌어요? Any question? Okay, so this is the first class, so I will start here. So because my plan is to introduce about this course, so I will stop here and then see you in the next class.